So so Sue asked, where do biofilms fit? And is that bacteria, viruses? Who's doing that? So biofilms. So let's picture this is self. So this is some part of you, self tissue. And so biofilms are largely bacterial. There's other microbes that can contribute, but it's largely thought of as a bacterial phenomenon. And so what biofilms are, there's these igloos that the microbes, the bacteria produce to kind of hide out from our immune system and from our testing. So I kind of picture it like an igloo here. And so you've got some self tissue, and if we color that orange, maybe it's gut wall or skin or, oops, well, that was ugly. This is self. The orange stuff is self. So you've got, say, your gut lining or skin or sinuses, all right? And so what happens is you've got this biofilm here, and at the lowest layer, the most inside, deepest layer of the biofilm, you have what are called persister cells, and they're dormant. So they're sleeping. They're just kind of in suspended animation. But the other microbes that are in these other layers of the biofilm, they're eating on your sinuses or on your gut or whatever they're connected to here. So they're not eating it so badly that they're going to kill you, because if they kill you, they lose, they lose their host. So they don't want to kill you, but they're eating you and causing some inflammation, enough that they can metabolize your tissue. Now, when antibiotics were invented, all we knew about were what are called planktonic bacteria or free swimmers, right? So antibiotics are great at killing free swimming bacteria. Bang, gotcha, no problem. But antibiotics are not good at getting into biofilms. So biofilms are communities of microbes. They hide under it, and antibiotics don't effectively get in there. So they might knock some shingles off the roof, and do a little damage, kill some guys, but they don't clear out the colony. So a classic biofilm type response, and the research suggests that 65 to 80% of infections include biofilms. Okay. And so the classic kind of life course of a biofilm-based infection is, hey, I've got this sinus infection or a gut infection or a UTI or some sort of infection. So we'll just use sinus for this purpose. I have a sinus infection. I use a certain antibiotic and the sinus infection goes away. I stop the antibiotic, and then maybe 2 weeks, 4 weeks later, the sinus infection is back. I take the same antibiotic again, knocks the sinus infection out. 2 to 4 weeks later, sinus infection is back. That is the biofilm, classic biofilm presentation. That's how you know, hey, or you should suspect biofilm infection there. Why? What's happening? Well, when the antibiotic, quote unquote, works or knocks your symptoms away for that short time, what it's doing is it's knocking enough shingles off the roof to make you asymptomatic. And so you finish your 10 or 14-day course of antibiotics, and then these bugs here, these persister cells, they wake up and they're swimming in the blood and guts of their buddies. And that's very nutritious. So they'll use that nutrition and they'll use that energy and they'll rebuild the walls to their biofilm. And, in 2 to 4 weeks, when the walls are back to the size they were or bigger, now you're symptomatic again. Okay, you take the antibiotic, you knock off some shingles to where you're asymptomatic and you think you're good. And then, when this happens in enough cycles, you start to pick up on it, or hopefully you would. So what we need to do is disrupt the biofilm, rip this whole roof off and deliver, grenades or heat-seeking missiles down into the persister cells and kill them. Because if you don't kill them, they're just going to wake up and rebuild. And so, you need more than antibiotics. You need antibiotics, you need biofilm disrupting agents, you need so another thing that these microbes can do is they have what are called multi-drug resistant efflux pumps, MDR efflux pumps. And what they'll do is they'll take in the antibiotic and they'll spit it out before it kills them. They've co-evolved that with us because, hey, you know, we've co-evolved together. They develop a weapon, we lose for a little while till we develop a response to that, then we win for a little while, then they respond, etc. So we developed antibiotics, killed the free swimmers. They move into biofilms, and our antibiotics don't penetrate those well, and if they do, they chew them up and spit them out before they die from it. So you need to use the antibiotics potentially, or natural antimicrobials. We need biofilm disruptors to rip the roof off, say, and then we need multi-drug resistant efflux pump inhibitors so that they can't spit out the antibiotic when we put it in there.